My name is Kulsoom Abdullah, and I'm giving the second part of our talks on using Docker. So my part will be on using a container that would already have what you need to use Jupyter, Pandas, and Python for exploratory data analysis. But first, we wanted to let you know that we'll have an extended session of the topics in these talks at an upcoming workshop called Data Science Con. They gave us a coupon that you could use if you'd like to attend. That's a $50 discount. And that's going to be at the end of November. And it's going to be predominantly about data science related topics if you're interested. Okay, and if you are already have a laptop here, or if you have or haven't installed the Docker image that you can use to run the notebook that I'll be going over in this workshop, we have that on our GitHub page.
Yeah, maybe you can click so that the link will be visible.
Oh, yeah.
github.com/datasciencepros
Yes.
/data_science_workshop. Yeah, actually, you can just go to Data Science Pros on the GitHub and then click on the Data Science Workshop link.
Yes, that's one folder. So this is the top level.
Is that your company, Data Science Pros?
We are establishing it.
Yes.
Establishing?
Yeah.
Oh, very good.
This is the first workshop we are doing. We will be doing education and also consulting in data science.
Great.
So we'll be in this, this is the folder that has what I'll be going over in Ozgur in the third session. So if you could either do either or if you'd like, if you're interested in getting the Docker image and then using that to run that so that you can use the Jupyter notebook. Or if you've already got it set up on your laptop, you could just go directly to this repo and clone it or manually download the notebook. And this is the notebook I'll be going over with the relevant data file in the data folder.
What does Jupyter do here?
Oh, so Jupyter is it's basically a notebook.
Okay.
And what it allows you to do is, in addition to having the coding interpreter, you can have embedded text in there, you can have images, equations.
Oh, I see.
And it's a way to kind of mix code in with other kind of elements in there instead of just a straight interpreter.
Helps you learn. Does it try to add meaning to the code?
I think that it does. I mean, for my use, I like to use it for if I look at someone else's notebook, I can look to see what they did. I can take little cells and run the code and step by step go through it.
There's a Jupyter notebook. They use it on a website called Coursera.org.
Oh,
Coursera
yes.
has a course on Python, and I was using Jupyter to, you fill out the notebook and then you can turn your assignments in as the Jupyter notebook, and it's got the text and then the code in is embedded and executes it in the notebook off of their server. So
Okay, and then within there you can submit
then
your
you can submit
code.
your notebook as your homework assignment. So that's why I was trying to see how Jupyter fit into here.
Oh, so for this purpose too, it would be similar in the sense of just going through the steps that you would take in the code, but being able to go through and then you could on your own modify cell blocks with code.
I guess
and
seeing
run
the
it.
example will be helpful.
Yeah.
Gotcha.
So for this, we decided to go with a housing data set. And if anyone has heard of a website called Kaggle, it's pretty popular in the data science community. They'll host, or people will host, or companies will host data sets. A lot of times they'll have competitions and challenges to work with a data set. They might have prizes. They might just have data sets up there just for you to be able to work on, and it's very community oriented. People will contribute what their ideas are, what they work on with the data. So that's what I'll be working with, is this data set. So I'm going to use a Python library called Pandas, which is kind of like a database in a sense, kind of SQL-ish. And it's pretty handy for working with data. And I'm going to be using that and illustrating what we can do with that. And then this work of exploring this data set and analyzing it and doing some processing with it is going to tie into Özgür's talk next, which he's going to take that data set and do a machine learning model with it. So to describe the data set, there are about 1,500 lines, so it's not very large, and you can easily just download it on your laptop and work with it. It doesn't, because it's not that large, it doesn't require anything, fancy or cloud or a lot of resources, so it's good for learning with. So here in this cell, what I'm going to do is I'm going to go to the actual notebook. Let's see. On my notebook server that I have. Actually, let me run that again. So, stop. Okay. As far as going through this, if anybody has any questions, let me know. I'll try to get through it, but please let me know as far as how much Python you know or don't know. I can at least guide you to how you would do this on your own. But with the Jupyter we were talking about, it's basically a notebook, and you can combine different elements into it. So with these, you can have these cells of different formats. So here I have a markup text. And this cell is code, so I can mix this all in there. And then if I run it, it'll actually run what's in here. And then these are the libraries that I'm going to be using today. One is the Pandas data frame. One is a popular library called NumPy. And then for plotting, one of the libraries I'm going to use is matplotlib. This is just so that I can have embedded plots in this notebook. This line means that, and then this just means that when I'm showing a data frame, I'm going to show more than 60 columns. I've upped it up to 100 so that it won't truncate it. So basically, Pandas is a popular library for working with data. Primarily, you have two data structures. One is called a data frame. One is called a series. So a data frame is two-dimensional. It's basically like, you could see it as an Excel spreadsheet or, say, a SQL database. And then a series is going to be like a list or an array. It's 1D. So under the hood, it's pretty fast because it's indexed as a hash table for a very fast lookup, and it's built underneath it is the NumPy library. So for the data set I talked about, I've already downloaded this from the website that I have linked here, and it's a list of prices that houses were sold for, and each row has features about that house that was sold. And so it's a comma-separated value file. Pandas has a built-in function to read those in. And so that's what I'm doing here in this function. Now that it's loaded, I now have a data frame called housing that houses this data. The head function is similar to the one that you have in Unix to show you the top 5 rows, and that's what you're seeing here. And so these are all of the features that it contains and what the actual data looks like in here. So you have things like what's the condition of the house, when was it built, all the way down to what we're going to call our target value is how much that house was sold for. And then these following lines, I'm just going to show you a few things you can do in pandas, but there's of course much more. So tail is the opposite, to show you the last set of lines in a file or data frame. And you can set one of the parameters as to how many that you want, which I'm demonstrating there. So parts of the data frame, you've got your columns, and in my case it was already in the CSV file. That's the names of everything that was at the top of the file. The index is something that if you don't specify it, it's just going to be numbers that are sequential. If you want to, you could pick something unique in your file. Like let's say you have people's names and they're all different. You could change your index to people's names. The shape just tells you that this data frame has 1460 rows and then the 81 columns. And you can...
Is there anybody following along? Not really? Nobody's coding? Okay.
So you read in the file using PD read.
Yes.
Then you can display at the first 5 rows. Now the CSV file, did it already have the headers in the first row?
Yes.
Okay.
So you run these commands when you have the Jupyter running. You run Excel by doing on Mac Shift Enter.
Yeah,
Shift Enter.
You could do Shift Enter, or you could say run cell if you wanted to use the GUI to do these commands. So you could use your keyboard for the commands or use that GUI menu. So here I could either do Shift Enter, or I could say go to the GUI and say run cells and click that. And I have some links in here, like such as the read CSV file. The function. These are all the different options that you have with this command. So in my case, I already have a header, so I just use the function as is. But if, say, your file does not have a header, or you need to read it from a certain different line, then you've got all of these options that they talk about here that you could use. Is that okay so far, everybody? Okay.
Also in a cell, if you just type a variable name and Shift Enter, it displays the
Whoops.
the previous lines.
Yep.
Is there a shortcut for that in Jupyter where you could be like, in a particular cell, you say, run everything prior?
The cell has that. The
Yeah,
cell menu has run all.
Like you could do run all.
Or run all above. Run
Yeah.
all below.
I just gotta go poking around the menu.
But there is, I think for pretty much all of these, there is going to be an equivalent keyboard command if you want to use that instead. The one that I remember now, the Shift Enter, is just if you want to run the current cell that you're in right now.
You can click on you can click on this to see other keyboard options. Like I don't know if there is like a run all.
Oh,
Yeah, run all cells above and below. They don't have a shortcut. If there was
Okay.
a shortcut, it would display it like this.
Good to know. Thank you.
You're welcome.
So like here, this is the Shift Enter.
Yeah, Shift Enter.
And then if you'd also like to know if, some of the other functions in Jupyter that you have, let's say you want to insert a cell above or below, and then I can add another in there and run it. Yeah, and then I could delete
Just
it.
trying to follow along with how the Jupyter notebook works. 'Cause it looks like a very nice tool.
Never heard of it before.
Yeah, so Jupyter used to be called IPython because it was for just Python. It became pretty popular, so they changed the name to Jupyter now because now you can use other languages, not just Python in here.
Julia, Python,
Yeah.
and what does the R stand for?
Let's see, Jupyter.
R. R stands for R.
I spelled it wrong.
Yeah. It's supposed to maybe tens of languages.
JPT, okay,
Yeah.
here we go. So, let's see, I think they have the list about us.
Yeah. All those languages were around Jupyter.
Oh, in the
print
name.
screen. Yeah, go to the print screen. Apparently, it is supporting all these
Oh,
languages.
that's right, okay, yes. So you've got your Python, your R, your Ruby. You can do Spark in there. Yeah, C#, PHP. Some of these other ones I don't know. I know they're growing.
We're just seeing some cool stuff.
Oh, no, sure, no problem. And yeah, just please feel free to ask me questions, because then I know what you all are interested in learning and knowing. But I like Jupyter a lot
You can see
because
it's a
it's
broad
nice.
learning tool. It's really neat.
And if you're interested too, so the way I have it is, since I like to do various data science things, Anaconda is a pretty popular package manager of popular libraries for data science work within Python and also R. So that has Jupyter in there. But it's nice because you don't have to worry about taking care of all these different libraries and updating them and everything. The Anaconda does that for you. So that's a pretty good tool. But if you don't want to use Anaconda, you can also just install it separately by yourself, by whatever Python version you install on your machine, by using the PIP.
Yeah, I'll
So as far as the data that I loaded into the data frame, these are some examples of how you could access certain elements of it. So a series or also a column, I can index it by the name of the column. So here one of them was house style. And I can chain that function with head and it'll show me the first 5 rows and what the house style is for those first 5 rows. And similarly to access a column, this is another style as well that you can use. And just a side note I have here is that usually when you name your columns to make it easier to access later is to not have any random characters or spaces and maybe something short. This part is showing you some examples of how you could slice or take certain subsets of your data frame if you want to look at it. So ILOC is to get a certain index by a number. So this is just showing you row 3 of that data frame. And something that's similar in Python, if you want to see a certain set of rows in your data frame, you can use a colon index where 10 would be the first row number I want to see, followed by the last one. So this is showing me rows 10, or the 5 rows after 10.
So will this support list comprehensions in Python? Can you do that in this notebook?
You can, yeah, so pretty much everything that you do in Python, you can do that in here. So if you, yeah, you can do a list comprehension as well. So just some other examples on how you can index and grab elements from your data frame. So here I said just show me the rows where the column value of the sale price is more than 450K. So that's what it's showing me here. So here's the sales price and those rows. And this is a sorting example where I'm saying here I want to see the rows where I want to sort them where sales price is the highest, and it's not ascending, meaning it's descending. So the top row needs to be the highest sales price, followed by the second lowest. And so the head is showing me the first 5. Ordered by what the top sales price is. And a little bit about data types. It's in pandas. It's similar to what you'll have in programming. You can have mixed data types in there, but a data type in one column has to be the same. So you can have integers and floats. And an object is a generic one generally for the strings. You can also have booleans, and you can have date and time stamps elements in your data frame. So in this particular housing data frame, we have 43 objects and then 35 ints and 3 floats as far as the categories. And then if you just want to see what each column is, you can use the D type or the get D type functions.
Can this pull data off of a database, like a SQL database, very easily, or does it take more work? I mean,
No.
Your data source is comma separated by these
Yes.
CSV files.
So in this case, yes, I had it already downloaded, but you can, whatever you can do in Python, you can do in this. So say I wanted to give the URL of the CSV file,
Right.
I could have that in here as well. Or like in your case, if you have a database, if you import the Python library that you need to get the functions that you need to connect to that database, you can also do that in this notebook.
So in the notebook, do you have to do the imports somewhere?
Yes.
Okay.
So it could be anywhere. So in mine, I have them at the top,
So okay.
but they could, yeah, wherever you need them, you could even have them in
So
later
Jupyter
on.
is somewhat like a script of its own. So you put it at the top and then it's available and put it down.
Yes, so all the cells underneath,
Gotcha.
as long as you've run that top cell,
Mhm.
and then
Go
if
to the
you,
top cell real quick.
oh, sure. So this is my first cell.
So import pandas as
Yeah.
PD, based upon the pandas, then you run
That's
everything
a
else you've
short-
shown so
yeah.
far.
Yes.
Foundation for Canada.
So one bad thing that might confuse people when they're using Jupyter is if you execute cells out of order, as you
Oh,
can
yeah.
imagine.
Oh, right.
So be
yeah.
careful about that.
Sure. So you-
Yeah.
You have to kind of treat it like a Python program
Yes,
itself.
just try
With
to
some-
run it one
with
by
some
one.
text augmentation and you get your outputs.
Right, because say if I go to another cell forward and I play around with it, but then I didn't go
Run
back
it,
and,
sure.
yeah, run what I needed before, I'll get an error, and then, but as long as you go back, you know, either do the run all cells or go back to what you needed to have run before what you're doing in your current cell, then it'll fix that. So we talked about, okay. So value counts, this is where if you want to, let's see in this case, house style. House style is an object. And so it has these labels such as 1-story, 2-story, etc. And so what value counts will do will say that of the different text strings that I have in this column, how many of each do I have? So there are 726 rows where house style is 1-story and etc. So that's what this function does for you. And here what I've done to explain is I've indexed the house style column from the housing data frame, and I've just assigned it to a variable called types. And so now this is just a series, or like a list. And now that, because it's a series, it can use the functions that series has, which one of them is the value counts. So to lead into what the next session will be on modeling the data with machine learning. And so a lot of work has to be done usually on the data before that can happen. And some of the things you generally want to do, regardless of what tool you're going to use, is you want to get an idea of your data, like if there are any blanks, if anything is missing, is there anything that you don't expect, and just what's the general distribution of it, of the values and the counts. So here the describe is a function that you can use. It's in the data frame in the series, and what that will do is it'll tell you how many there are, what's the mean and standard deviation, the smallest value and the biggest, and then the different percentiles such as the median and the quarter and the 3/4. So in some of these columns, they're actually numerical values. So like, for example, year built is 4 digits of a year. And so this describe function will treat it as a number. And it will do that for your strings as well, just to give you a caveat on that. But usually this function will be more helpful for numerical columns, such as here if we look at sales price, which is it's an actual number value. It's giving you the count of how many of the rows actually has a value for that column. And then what's the mean sale price? So that's about the 180K. And then you get the standard deviation and max and such. So it's just a function that helps you to give you a quick idea of the distribution of your data.
Can you do anything to control the numerical format? There's a lot of trailing zeros there.
You can, let me see. For the describe function specifically, let's check. But I know there is some.
Yeah, maybe.
Yeah, so here's the describe documentation.
Yeah.
Okay.
That is so cool.
Let's see, absolute value.
I guess it's.
Yeah, one of the good and bad things is that there's a lot that you can do, and so that because of that there's a lot of documentation. But
To me, it's kind of like this. Like I can.
Anyway, it's more like for experimenting with early on. Jupyter is best for experimenting and seeing results.
You're going to show this as a report.
Yeah, this won't be like the end product. It is for your.
no, it's just I mean, and you wouldn't you wouldn't want to show this to someone who doesn't want to see any code. This would not they would not like this. So it's just usually it'll be maybe your peers or people who are interested in seeing code and some documentation and description. So as far as this data on Kaggle, where I've got it from, they describe what each of these columns are and the different values in the format. So I've just listed them out here, but I've separated them into which ones are actually floats or integers, and then which ones are categories like sale condition, new, old, etc. They're going to be different strings for those kind of fields.
When you're starting out, just going through some training data, like do you, like with the describe function, right? Like I was trying to figure out like where are the best places to start? Like how might I use the results from that to decide like which things I would want as signals into like a later algorithm, or like or which ones do I want as features and which ones do I not care, like based off of that described data that you looked at, right? Like
Yes.
So some of the machine learning models will automatically choose, you of course give some parameters to it, but it will automatically choose the best features to train the model. And for some of them, you can do some pre-processing. There is like some other algorithms that will choose you or map the current features into another feature space. Like principal component analysis.
Oh,
would have
right.
to be transformed, right?
Sorry?
Like the strings that you have would have to be transformed. Like
Oh,
one
yes.
story, two stories. Like that have to be
She will map
transformed
it
into
now,
something
yeah.
binary.
She will show it now.
Numerical.
Yeah, so for that part, like for example, for the numerical values, I'm just leaving them as they are, since it's an okay, input format. But say for, so for dealing for the different situations, like the ones you mentioned, like if it's a category, or if it's something nominal, like,
You map them into it.
oh, sorry?
You map them into integers, the categories.
Yes. So there's a function that will help you to do that. The other thing I'm addressing here as well is how many missing values are there, or nulls. So that's what this code here does. It's showing me of my columns how many are blank. So pool quality, 99% of them do not have a value, for example. And missing data is another thing that you want to deal with when you're pre-processing. So I have that handling all three. So as far as, say, the missing data, you could just drop it. You could also impute it, which means fill it in with something. And then the describe function could be something that could help you with that, is to say, well, do you want to fill it in with the mean, or the majority value, or the median? Or you can do more complicated things to say, try to predict what that value should be. So depending on what your use case is, and if it's going to maybe help your model or not help your model, that would help you decide what you want to do. Or you can just experiment to see what happens when you try a certain way of dealing with the missing value. What happens to your model? So
But you don't use you're not looking at that describe data and being like, okay, these are automatically the features I'm going to care about, or these are automatically the features that I need to exclude. Like you're not looking at it from that point of view.
No, actually, usually at this stage, I'm still just looking at the data, not even yet to the modeling, or just trying to see what do I need to do with it before I can even think about that part. So here I have commented out, because at first I had thought to drop these where they had the majority of values missing. But this is how you would do it if you wanted to do that. But for now, what I've decided with Özgür is I just left it for his session, so he can show you using all of the variables. So what I did here is I said, all right, for the columns where it's not a numerical value, and that that has missing values. Actually, sorry, let me say that again. These are the variables that are numerical and have missing values. And I just wrote a function to use the describe to see what are the means and the mins and the maxes and all of that to help me decide what do I want to impute these missing values with. So after looking at that, what I decided to do is I've treated them, each of them individually. So say for the pool quality, I decided to fill it in with the majority, or just the option of that there is no pool. And that would happen to be a string. And so this fill NA function will fill in all of the missing values with that. So say this numerical value, lot area, I decided to fill in the blanks with the mean of all of the values that are there. Similarly for lot frontage. For the rest of these, these are categorical variables, and one of the options in the category is that it does not have that thing. Like for example, for the garage, it doesn't have a garage. That was the NA. It doesn't have another feature, basement. Then these two values, they had numerical nominal values, so I just went with the 0, which means it doesn't have it. So there's different ways you could treat this, but this is just an example of if you decide to do this or fill it in with whatever, this is how you could do it. So yeah, if you have domain knowledge, or if you know the background story of what's going on, that will definitely help you decide what to do with this. And sometimes if you don't know, which could be the case a lot of the times, is then you have to experiment and see. Okay. See, for the nominal values, like for example, external quality, and this was in the data dictionary as well. These different strings represented poor for PO, FA for fair, forgot what TA was, good, and excellent. So to deal with the nominal value that's a string, I have to convert it to a number. So I wrote this function, and of course there's different ways you can handle this, and I just wrote the mapping manually that I want poor or PO to be a 0, fair to be 1, etc., up to excellent being the 4. And since a lot of these had their own set of nominal categories, I had to do these. I was going through them manually because I didn't know. But in retrospect, if you already know what they are, or many of them are the same, you could just write a function to make this cleaner instead of being so much code. But that's why I did this the way it is now. So I did this for each of them. And then I just added an extra column, like say for basement exposure, I added this column called basement exposure coded, which will just have the numbers in there instead of the strings. So this is just printing what I've done up here, which is to do a little sanity check of what were the counts of each of these nominal options. And then after I did the coding, what are they and for which integer? So like TA was my 2. I still have 906 rows, so just to see everything was okay.
So, I'm sorry, go
Oh, sure.
there. So you're using value counts to summarize text data?
Yes, and you can also use that on numerical data.
If you want to compare the numbers match before and after
Or that I still have the same counts
for the corresponding.
Yep, code. So like fair, so NA was a 0, and you can check in your own code too. And I do have 37 rows with that. And of course you could go deeper to still, just to check to make sure everything was okay. No bugs or anything. Okay, this is these were the categorical values that don't have necessarily a logical ordering. So one way to deal with that is to do something called one-hot encoding. And so what that will, it's called one-hot encoding.
One hot?
Yeah.
Yes.
Like cold hot.
Okay.
Everything else is cold. One of them is hot.
Like
So
you'll
that's
have
why it's
zeros
called
and a
one-hot
one. So it's like,
Gotcha.
got, okay. But yeah, I guess it makes me think of the, computer binary type code. Like if you have, let's see, what were some of these? Roof. Like if you had brick, it'll break it out. Like let's say roof, there were 3 types. Like say there was brick, I'm just making this up. And there was, stone, and there was, so what it'll do is it'll create 3 columns for each row. So if say for a certain column you had stone for that roof, it'll put a 1 for stone and then a 0 for the other 2. So that's what it's going to look like. So this function here, this PD get dummies, does that for you without you having to go through that work. So what it'll do is it'll go through and say, all right, if roof had 3 different types, it will automatically figure that out for you. Do the, create the 3 columns and then do the coding for you. So here, after all of the work above, I reran this code, which is to count how many nulls or missing values I have in the percentage. So now everything looks okay. So now I have no missing values. And this is what the data frame looks like now. So I didn't remove those columns that I've encoded. I just added extra ones. So like, for example, basement, there looked like there were 2 types. There was one with a full bath and one with a half bath. And so this is encoded according to what that row's value had. And now all of these are all there. Okay. Then what I did to pass it on to Özgür for the modeling is now can save this modified data frame to a CSV file for him to use, or for yourself. So that's what this code does. The last part of this notebook, again, like everything in here, I'm going over it very quickly because there's just a whole world out there of what you can do. But for visualization and for Python specifically, there are various popular libraries that you can use. So I've listed some of these here. Matplotlib is a pretty popular basic one. Pandas, which is the data frame I've been using, that you could also just use matplotlib functions with that. Seaborn I used in this notebook to show you a pair plot and a heat map. These 5 I did not use. These are pretty good for various reasons, and I've linked to a presentation that, if you'd like to see it, goes into a lot of detail about the visualization and all of the libraries, and there's a lot.
Are there any visualizations that are more like your go-to, like where you'll start when you're first exploring the data? Like you might use a scatter plot first, or a histogram or something first. Like, do you have a preference?
For me, for distributions, I like to look at that. So I might use, say, the histogram like this, where I'm just looking at one variable, and then then maybe the scatter plot if I'm thinking, okay, beyond one variable, now I want to compare 2 and see what the relationship is. So usually I'll start basic like that. And in this case, I just said, all right, let's look at the sales price since that's our target value, and what is that distribution. So with the pandas, I just said, all right, let's I can use the histogram function directly on that column, and then it'll automatically generate it for me. So here, this x-axis, with the x-axis, it shows you the whole range of all of the sale prices. And then the y shows you the count. So here you can see most of the sale prices are between 100K and 200K. And then you've got a few houses that are in this higher range and so on. So that, so looking at something like that can help you decide what the data looks like and maybe if you want to do anything with it before modeling. So with something like this, some might say, well, you know, these are really high prices. Are they real? Like, are they outliers? Are they going to mess up my model, or are they actually important information that's going to help me in my model to, say, predict a sales price? And again, either if you already have knowledge about the data, or you might want to experiment. So something I did here for, you know, I say for fun, was I just wanted to do a pairs plot, and that's supported in the Seaborn library. So I just imported it here. And I thought, well, I'll go ahead and take the columns that are just the numerical values. And so what a pairs plot does is it shows you the correlation of every single variable to every other single variable. And I have a lot, so that's why this is really tiny. Yeah, so it's not very practical. But what you're seeing is that for each row, right here you're seeing the distribution of that variable. Like here, this is lot frontage. That's that row, and lot frontage is that column. So this is going to be the distribution of lot frontage. And then when you move to a different row or column, you're seeing the scatter plot, which is the relationship of the two variables. So that just is something to show you the big picture.
So then, can you zoom back in?
Sure.
So then in like the second column, first row, it looks like then they're highly correlated, is what we're saying?
Yeah.
That's what this is showing us?
Yes, or at least it's showing you what it is, but it's as far as the core, it's showing you what it is, but I guess in this case it's not that correlated.
Scroll down here, there's
Like
some
what
others
would
that
it
are more-
look like if it was highly
Yeah, I'll
correlated?
show you.
Yeah,
Okay, I'll show you those examples because
This one is a little bit correlated, I think. looks
Yeah.
like.
If you click on it, it'll open up, I think. Yeah.
Okay, cool. So this is lot area.
And then you have so much variables actually.
Yeah, that was not. Oh, I think I crashed the Safari. Yeah.
I did it.
Let's see. Okay. But I have a few smaller plots that are easier to look at.
So then, were you trying to point, like, if it was highly correlated, you'd have just a line,
Yeah.
like the.
Or the
like
points
at
would
a
be very.
45.
And also if it is like this line, then it will be reverse correlated.
Okay,
So when one is increasing, the other one is decreasing.
okay, so if all the dots
If they-
of the scatter are forming a line.
If they are
Gotcha.
aligned like this or this, there's a correlation.
Yeah, and they're very close together. So something I did here was I used a heat map to show what the values were using a correlation function. So what this does, and I'd seen it illustrated, is it calculates the correlation between two variables, and I pass that same list. And then then I printed here to see what were the actual correlation values to sales price. So sales price to itself, that's one. And then I've got it sorted to see which variables are the most correlated to sales price. So here, overall quality is pretty high. The living area and feet cars, and then all the way down to the values that are not really correlated or have negative correlation to sales price. You can use the heat plot to if you want to visualize that. And then what I did was I said, all right, of the variables that had the highest correlation, I did the scatter plot. So in this case, I have sales price and the living area as a scatter plot. So here you can see the pattern of that is most of them are close together, and they do go up generally as the sales price goes up.
So each of them basically is an instance, as you know, in the scatter plot. So the house that has 4,000 something square feet has this value for this instance.
Yes. A little, yeah. I do that here for overall quality as well. You can see a similar relationship that as the sales price goes up, you're going to have a higher overall quality. Just one line I wanted to show here is the idea of sampling. And in our case, it's not that important because we only have about 1,500 rows of data. But if you're dealing with millions or billions, you'll want to sample. And there are some nice built-in functions that will do that for you, where it will just randomly grab points in your data. And in this case, it's taking 30% of it. And then that way, if you want to run it, whether you want to visualize it or work with it, at least that hopefully that random sample will give you a manageable set of the data that will hopefully still look like the original data. So here, the example I have is this is all of the data plotted with the relationship of sales price to the living area. And then I ran the sampling to just grab 30% of the data, and I did the same scatter plot, so with just 30% of the data. So we do have less, but because it's a random sample, we could at least still see the relationship, that there is a trend going upwards, and it goes up as the sales price goes up. This is just something extra I showed you just for general visualization, instead of doing plots separately. If you want to, organize them for space and presentation, this is just an example of doing a 2x3 set of graphs, and you can put those parameters in here, those values, and then it's a similar indexing where you want to place your graph. So these plots that I have here, most of them are the same ones I had above, but I'm just specifying where I want them laid out in this figure. And there's a whole world of things you can do with this. So you can annotate it, tweak it, colors, all that kind of cool stuff. So I just have one example here where I specified where I wanted the plot to be in this arrangement and what I wanted the color to be and the X and Y label. And just for exploration, I thought I'll just do a line plot to show what was the number of houses that were sold each year. So if you're familiar with a function called group by, it's in SQL. You can do this in pandas. So what this is doing is it's saying for that category or that column year built, I'm saying I want to count how many rows I have for each unique value of year built. And then I'm using those numbers in the plot for the line function. And this is what I had shown above, but it's at much smaller scale, this pairs plot. I just picked the columns that had the highest correlation to sales price, so this will be easier to see. So this first column is sales price, the first row is sales price, and then here, this relationship is sales price to overall quality, to the living area, to the number of garage cars. And the nice thing about this is if you want to also see the relationship of the other variables with each other, this gives you a big picture. I guess if anyone has any questions, or we can, when Özgür gets back, he's going to take the data that I cleaned up and processed, and he's going to do linear regression and show you the modeling, the predicting the sales price.
Is this experimenting ultimately translated into a script that cleans up data, or is it a one-time thing that you do for one data set?
Oh, well, for this, so this Jupyter notebook, it's actually it's a JSON file. So if I'd have to take the code parts, or just export those Python code parts for it to be, say, a separate Python script. But if someone took this notebook and they ran it themselves on the data, then you could repeat this process using the notebook if you wanted to.
You can use a notebook with a different data set.
For some parts, you could. I mean,
They have the same structure, the same.
Oh, if it's the same structure and column names, etc., then yes.
But I mean, it's important for repeatability of the experiment, the results.
Yeah, so what you do ideally is, let's say you want to use Docker, then you wouldn't have to worry about somebody having all of the right libraries and all of that, and have the same the data set in the same format for that person. Then they could repeat these. And some other things you might want to do for repeatability is if, like, say, the random selection of data, you can set a seed, it's a parameter, to some number. That way, that random generation will give the same result, yeah. So then if someone else runs it, they'll get the same values. Oh, sure.
What kind of model do you use to try to correlate the price to the other house features?
Oh, when I just did a basic
It's a linear model?
Yeah, it was just a correlation function, but Özgür's going to talk about the linear regression. But I just did more basic cleaning up and just checking two variables. Okay.
Statistical tests, is that all in pandas as well, or MATPLAB, or is there something else for those?
You can use a library called, there's different libraries you can use. The pandas is going to be more just your basic functions, but you could use those other libraries like the NumPy or the stats models within Python on the data that you have in pandas to do more advanced functions or statistical functions.